the velocity changes uniformly with time. Velocity changes uniformly with time. Now, these equations basically establish relation between the following quantities like displacement, time taken, initial velocity, final velocity, and acceleration. Now, what was the need for deriving the kinematic equations? Basically, our aim of studying the physical phenomenon or the phenomenon related to motion or mechanics is to use it in our day-to-day life. Now, with the help of these equations, we will be able to calculate the values based upon the data given. So there were three equations, those are the three kinematic equations which relate all these quantities and with the help of which we are able to calculate various values in our day-to-day life. We will see them one by one. So let us see what are the three kinematic equations. The first equation is before we start with the equations, make sure that you remember the notation because it is not possible to write what they stand for everywhere. So we will just be using these terms hereafter. So just make sure that you know A is acceleration, V is final velocity, U is initial velocity, T is the time taken, and S is the displacement. So we will be using these notations hereafter. Now let us start. The first kinematic equation is V is equal to U plus AT. The second equation is S is equal to UT plus half AT square. And the third equation is V square is equal to U square plus 2AS. These three equations are very important equations and you should practice them so hard that you get used to with the three equations. You should learn these three equations and keep them in your mind. V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. We will discuss each of them in detail. We will derive each of them and we will solve a couple of problems related to them so that you get very much familiar with these equations and their applications. Let us start with the first equation, that is V is equal to U plus AT. As we have told, V is nothing but the final velocity, U is the initial velocity, A is the acceleration, and T is the time taken. Now let us try to derive it. Now from the definition of acceleration, how do we define acceleration? It is the rate of change of velocity with time, that is dV by dt. What is dV? It is nothing but change in velocity. Now what we are saying here is initial velocity is U and final velocity is V. That means what is the change in velocity? Final velocity minus initial velocity. Now this divided by the change in velocity takes place in time t. So this dt is t. So we find A is equal to V minus U by t. So we can write this as AT is equal to V minus U. This implies V is equal to U plus AT. Very simple, right? So this equation is nothing but it is an alternative form of the definition of acceleration. I hope it is very clear and there is no doubt in this. So let us go ahead and proceed with the second equation, that is S is equal to UT plus half AT square, where S is the displacement, U is the initial velocity, T is the time, and A is the acceleration. In this case, since we are deriving an expression for displacement, let us see how we can calculate displacement. As I already told you that in case of a velocity time graph, the area under the curve is displacement. Now, we also know that these three equations are applicable for uniformly accelerated motion. Now, if it is a uniformly accelerated motion, any motion can be represented by a straight line. Now, according to what we have studied, we know that area under this curve would be equal to displacement. Let us try to find the area of this entire thing and let us name it. Say this is O, this is A,
B,
this is B,
C,
this is C. How do you think we will be able to find the area of this trapezium? Let us draw a perpendicular here. This is point D. Now we have divided this entire figure into one rectangle and one triangle. So what we can say is from this figure, displacement, that is S, will be equal to the area of this figure, that is area of OACB. Now area of OACB will be area of OADB, which is a rectangle, plus area of the triangle BDC. Now, let us find the area of this rectangle. The rectangle area would be length into breadth, that is OA into OB. Now, the area of this triangle would be half into base. Base would be BD and BD is equal to OA. So, half into OA into height. Height is equal to CD. What is OA? OA is nothing but time, that is T. Similarly, what is OB? Now let us suppose before we do that, we have considered that this line, this straight line displays the uniform accelerated motion. That means this line shows that this was the initial velocity and this point corresponds to the final velocity. So the initial velocity is U and the final velocity is V. Correct? Okay. So OB is equal to U. Similarly, CD. What is CD? CD is equal to, we can say this point as F. So CD is equal to BF. And what is BF? BF is equal to OF minus OB. Now what is OF? It is V and OB is U. Now we will put all these three values in this expression. So what do we find? S is equal to T into U plus half into T into V minus U. So now this is UT plus half VT minus half UT. So now we can write this as UT plus half
AT square
V minus U into T. Now from definition of acceleration, we know that acceleration is equal to V minus U by T. That is the change in velocity by time taken. So now instead of V minus U, we can write V minus U as AT. So we will put V minus U as AT into T. So this will be equal to UT plus half AT square. So I guess it is not very difficult. It is very easy to understand and you can derive it very easily. That is, we have derived displacement is equal to UT plus half AT square. We know that for